Hi, hello. My name is Isaac Vidas, and I'm going to talk to you today about data mining and integration with Python. If you want to reach me afterwards, you can also use the other methods. So a little bit about my background. It's my first time in Texas, so howdy. It's been great so far. I've started as a software developer in the Israeli army, and might be the reason that you detect some kind of accent. I also have a background as a security software engineer, and a few years ago I joined Desti as a data engineer. Desti was a startup, and it was an app, a travel app, that you could use to search for points of interest around the world and around you. So you could use it, for example, to search for romantic restaurants in San Francisco, or you could search for family-friendly attractions in Dallas, or centrally located hotels in New York. And the app will give you back results that will be ranked according to your query. And it will be a list of points of interest. And if you click on one of the points of interest, you would see a similar screen based on what you clicked on. But this screen shows a lot of information. And it basically shows you all the data that we were able to collect for a certain point of interest. So this is actual screen from the application. And you can see here that the name of the POI, which is Moray Woods National Monument. We can see the category. We can see it's a monument, which is an attraction by the camera icon. We have here images that we were able to collect from Facebook, Foursquare, Instagram. We're able to classify this POI as an excellent monument and also say where it's located specifically. We can also give a few features about this point of interest, such as it has sequoia trees and you can do hiking. We also have a list of articles which mention this POI. And we can go to different external resources that we can read more about. And here we have the contact of this point of interest. So that's a lot of data that we're able to acquire and do content acquisition and match together, blend it, and serve to the user. So he will be able to know exactly where he's going and what he should expect when he's getting to his destination. So let's build a system for data mining. And this is just a sort of an example of how you might do it. But the thing that I want to show here is that on one side you have the application server that serves the users, whatever client they're using. But on the other side, we have the content system, which basically is being used to collect data, to extract whatever we want, to clean it, and to integrate everything together and give the user back a meaningful entity. So, and just remember that this is an example for how you would use such a system for getting point of interest data. And you can basically do the same for collecting information about movies or books or whatever you feel like. And while you're collecting your data and doing the data mining, you follow a certain workflow. And it has basically 4 steps. So the first one is doing the content acquisition. You are going to all of your data providers and you fetch data from it. Afterwards, you're trying to do enrichment and maybe get specific data, more precise data for a specific point of interest or specific object. After you've done collecting all of the data, then you're starting to do something called entity resolution. You would want to start to match the same data, the same type of data from different content providers. And in the end, you would want to combine it all together, save it in your database, and serve it to the user. So when the user will search for point of interest or a romantic restaurant, it will be part of the result. So the first step is content acquisition. And surprise, surprise, it's also a workflow. So you start off by extracting the data. And this means that you'll go to all your data providers and you'll get as much data as you can. Then you go on to clean it, normalize it, analyze it. When you analyze it, you will probably see a few issues, and you'll go back to cleaning the data. Now, I want to focus on the first step, extracting the data. That's a very good point to save your raw data. If you've scraped something, if you harvest something, if you queried something from an external API, just save it. It will probably have data that you will need later on, and it will save you the trip. This step the content acquisition step takes a lot of time and effort. It's very time consuming. The good thing is that you learn a lot about your data, which will be helpful at later stages. Once the data is ready and we think it's good enough, we can start to integrate it into our system. So for our example, let's say we have a list of content providers. Foursquare, Facebook, Instagram, Wikipedia can be used for a lot of other things. We have a lot of data, other data than specific points of interest in Facebook. However, hotels combined will give you specific data about accommodations. So it really depends on what you're trying to build. From each of the content providers, we will want as much information as we can get from it. It will help us a lot later on. Some of it is, of course, the name and address, the geo-coordinates. If it has a phone, a website, or email, it will also be very good, both for the user and both for us. And whatever other details we would want to get, and of course, images. Images are very important. So this is just like a skeleton of a general harvester or worker. He has a very, very simple job. Connect to external API, get whatever we want from it, and pass it on along for other functions such as normalization and saving it in the database. For each worker, we will have a type of driver. And the driver is basically starts the harvester, starts with an infinite loop, and it will basically just wait for new tasks to execute. And a task will be, give me information, find information about the Golden Gate Bridge at this geolocation. And the harvester will do whatever it does and send the data back to the server or create other tasks, such as now I want to get images from Instagram for this point of interest. This is just an example of using the Wikipedia API. So you send to Wikipedia the latitude and longitude of a point of interest, such as the Golden Gate Bridge, and start searching for articles that are similar to what you're looking for. So what you're doing is calling Wikipedia with a geo search, and actually this is a package that I've added the geo search function and contribution of some sort. And you get back the results, and you iterate them and try to find a title that might match in some way to what you're looking for. Once you're done, then return it and start doing more analysis on it. When you collect your data, you would want to normalize it. You would want to make it as simple as you can for later stages, such as entity resolution. So you'll be able to match quickly and better different POIs from different content providers. So for this example, we would probably want to normalize everything, the description, the categories, everything we can. But for this example, I'll show just the POI names, addresses, and phone numbers. So for example, let's take the Phoenix Hotel. We can have different variations of it from different content providers. So the second one might have a stop word, and the third one will have the city name, and the fourth one will have, again, the city name, but in an alternate name of the city. And the last one will be a little more complex and might give us also the brand of the hotel, which is very useful, but we need to know how to act when we get it. Another example is normalizing addresses. So this is the same address in different ways, and we need to be able to normalize them. So we can later on match them together and say that all of these addresses are basically the same one. And normalizing phone numbers. We might have the phone number in different variations. We might have it with the country code or without. Either way, again, this is basically normalizing the phone numbers, I think, is a very simple step. Once we're done collecting our data, we would want to start maybe doing more specific tasks on it, such as collecting images for points of interest. In this example, I'm showing Instagram, which has a very nice API, a very good API, and very helpful, because Instagram has the ability to pass on a Foursquare POI ID or a Facebook POI ID, and it will return back images for that location from Facebook or Foursquare. This is basically because Instagram started off basing their location model on Foursquare, and later on, of course, they had to base it on Facebook. So this is a very, very good API for what I looked for, and it's very easy to use. So you send the Facebook ID or Foursquare ID, you get back images, and you save yourself the entity resolution step. Another example of using the Instagram API is to search for images of point of interest at a specific location. A complex example will be to try and fetch and try to find images of a trail, a hiking trail. It might not be that famous, so it won't have a representation in Facebook or Foursquare, but if we'll have its geolocation, and we will be able to search for images around that geolocation on Instagram. After that, we can try to filter images that has specific tags, such as hiking or trail or nature. And I play with it a little bit, and it's working. I mean, I was very surprised by the results. And of course, it won't work for all kinds of points of interest. If it's a restaurant and you'll search for food, then you might get other results. But still, some cases are very good use cases for that. After we've done collecting the data, enriching it, and we have a lot of data for our use, we can try to match it together. What we would want to do is take the Golden Gate Bridge from Facebook and say that it's also the Golden Gate Bridge from Wikipedia and match them together. This way, we will have a single entity containing all of the data from Facebook and Wikipedia instead of like 2 objects and each one of them with not a lot of data. So we would want to be as good as we can in this stage, and normalizing the data and collecting all the things that we can will help us to achieve this goal. And things that we wouldn't want to match are the Golden Gate Bridge and the Golden Gate Bridge Cafe. They have a very similar name, but obviously it's not the same place. Another example is, well, I'm from Boston, and there's 2 POIs in Cambridge. So one of them is the Cambridge Common Pub or bar, and the other one is the Cambridge Common Park. And they're very, very close together, but you don't want to match them. One of them is an excellent pub, and the other one is a nice park by day and might be a creepy place by night. So if you match them together, you will have a mess, and showing it to your users will not give a good experience. Another specific example for points of interest and how to match them is using their size. So Golden Gate Bridge is considered a small point of interest, and Facebook and Foursquare might say that it's in the same location, and maybe Wikipedia will say that the Golden Gate Bridge location is located on the other side. But when we're doing the matching and we search for points of interest at a specific radius, we can use we can analyze the size of the POI based on its name or categories or additional information. And when we do that, we're able to use this kind of information for our matching ability. In the other side, we have the Yosemite National Park. And Wikipedia might say that the Yosemite National Park is located in the middle of the park, but other content provider might say that the location of the Yosemite National Park is one of its entrances, and they are located kilometers away from each other. So we want to be able to know how big is the radius that we want to search for candidates for our matching abilities. This is an example of how we start to do the matching. So we try to match the name, we try to match the address, the location, phone, website, whatever we can. There's a long list. We try to understand if it's a big POI, or maybe how big is this POI based on, let's say, his category. If it's a national park, then it's a big POI. If it's a restaurant, probably not that big. Once we're doing that to all the candidates that we're looking for, we'll create a list of possible candidates, and then we will try to estimate which one is the best match for what we want to try and what we want to find. If we have too many POIs for too many matches for a specific point of interest, it might be that we have bad data or that we have a bug in our entity resolution code. If a popular POI, such as the Golden Gate Bridge, has no matching, and you look at Facebook and you can't find the Golden Gate Bridge, and you look in Foursquare and you can't find the Golden Gate Bridge, then it's probably also an indication that there is an issue. Once we're done with that, and we think that our entity resolution is good enough and we collected enough data, we will start to combine everything together. So we'll take the description from Wikipedia, and we'll take the images from Instagram, and we take, I don't know, the likes, the number of likes from Facebook, and the number of check-ins from Foursquare, and we'll be able to combine all of them together to give the user like all of the details that we can. Once we're doing that, in that step, we can try to use the data to extract more data from it. So for example, if we look at the Yosemite National Park, we can understand that it's a national park just by looking from the name. The same thing will go to a museum. It will probably have the name, the word museum in the name of the point of interest. Or if it's a forest or a lake or whatever, most of the time you will have the category inside the point of interest name. Sometimes it will be confusing. There's a store called Johnny's Cupcakes, and obviously it's not a cupcake store, it's a t-shirt store. It's in Boston. Another thing that we can do is to analyze the description and try to find specific categories inside it as well, or features, so we can understand that the Yosemite National Park has forests or waterfall or valleys, and it's also a popular spot. This can help us also to rank our points of interest when we return it to the user. So once we've done all of this and we went through all of our workflows, there are some lessons learned that took a lot of time to collect. So the first one is that you need to have a content methodology. This means that what you basically want to do is to integrate new or updated data into your system as fast as you can. And obviously, if you're working in a startup, you would want to run as fast as you can. You would want to show new content and new data to the users and to the rest of the group. So a content methodology might be to take a small sample of all of your new data. Just take a small amount of points of interest or specific cities around the world and do the whole workflow only for these POIs. Do the content acquisition, the enrichment, the entity resolution, the blending, everything, just for a small proportion of your data. Integrate it into the system and show it to the users and maybe collect some samples or feedback. And you can also do it on your staging environment just to see and to identify flaws before showing it to your users. And this is, from my experience, it's very good to have like a built-in methodology around content. Once you have this kind of process, then it's very easy to just do it for each for new content providers that you're adding. And it will save a lot of trouble and time later on. Now, I want to focus on the first step. So the first step in the content methodology is to take a small sample of POIs. And this is a very critical and important step because it will define how good you're going to integrate your data, obviously. So you need to take a very good sample of your points of interest. And just, I mean, you can try to get a better idea of how good the rest of the content is just by checking that small sample. And when you do that, and you're trying to take percentage of how good your content is and how much duplication or duplicate rows do you have in your data, you need to remember that 87% of statistics are made up on the spot. This is a joke, obviously, okay? So make sure that if you're doing some sampling, also use random.seed, it will allow you to reproduce your sample in a very quick and efficient way. And you'll be able to, if you'll afterwards think, oh, maybe I didn't check that, I want the same sample again, you're able to do that using that. And when taking a sample, consider the following. Is it a good quality? Can you reach a decision based on that? Do you have enough samples in your sample? Can you use it for another task or another strategy? So you need to think very, very hard about what kind of sample you're taking from your data. When integrating data to your system, adding new or updating, you should test it. It will save you a lot of time. If you have a staging environment, test it on your staging environment. It's very good to copy the production to your staging. The database, it will help you to test your data on whatever the users are currently watching. And it's a lesson learned. So what is bad content? So bad content might be bad Unicode or characters or HTML inside the text or some other garbage or duplicate records. But it might be content that you don't want to use or content that you don't want to show to your users. For example, getting images for hotels from Instagram that users took. I mean, this is an image that I took 2 days ago at my hotel. And I don't think anyone will want to visit that place if they'll search for it in the app. So you really want to analyze what kind of content you want to use for each use case. Another example that we had a while ago was some guy just had this, I don't know, maybe it's his art or maybe it's his hobby, to go to hotels and take naked pictures of himself and post it. So we had one that integrated with those kind of pictures. And can you imagine pictures of naked people on the internet? I mean, yeah, so yeah, that happened. And so, yeah, check your data, see what's good for it. And when you think about it, these are the kind of images people will take at hotels. Another use case are restaurants. Restaurants are very good kind of POIs to fetch for images from Instagram, because users will post pictures of themselves with the food, eating it, enjoying. It's a very good thing to add to your point of interest. So when we detect or suspect that we have a content provider that is providing us with bad content, we want to be able to suppress it or disable it in a click of a button. In this example, you can just add a flag to your content and make sure to the content provider and make sure that you have in your code, before you're showing it to the users, you're able to suppress at least some of the content details. And if you're doing it correctly, then you can do it in a very, very efficient way. Another thing to do is to hide only specific type of data. And if it's hotel availability feature that you're not sure about, then wrap it with a feature flag and enable it or disable it whenever you want. Most of the time, people will use feature flags for a specific feature, but you can also use it for your data and what kind of data you want to show to the users and what kind of data you want to hide. Reports and dashboards. So dashboards and reports are very, very important. You, as a content owner, you would want to know the current situation in your data. How many POIs do you have? Where are they located? Maybe show a map of where are most of the POIs, what kind of categories you currently support, how many POIs are visible to the users, and so on. So it doesn't matter what kind of report you're using or what kind of engine, PyTexas or whatever the name is. I found it recently and it looks good. I didn't use it yet, but I think it's a good example. And it really doesn't matter. You can write your own dashboard or your own reports that will send you the report daily. It will make your life easier and your manager happier. A little bit about entity resolution issues. So, one of them is overmatching. When you have overmatched POIs, then you will have that Golden Gate Bridge Cafe example, where you have the Golden Gate Bridge POI, and inside it you have information about the Golden Gate Bridge Cafe. This is the ship that is hiding around the alpacas. And it might take 46 days to find it, and it might be forever and it all depends on your reports and testing. So a good example of that, well, this is an actual screen. So the Glen Rock in New Jersey got mixed up with Dwayne Johnson. And believe it or not, the classifier classified it as an average geologic formation. And this, I mean, I can't believe this happened, but it was amazing, and I was very fast when I removed it from the system. But still, it might happen. This is a clear bug in entity resolution. Specifically, the issue here was that the entity resolution didn't check the geocoordinate of Dwayne Johnson. If it did, it would find out that Dwayne Johnson has no geocoordinates and won't match it because it's not near the actual POI, and it's not a POI. And there are other issues and hilarious issues. Another issue that might be is undermatching. So it means basically that you will have duplicate content. So if we can't match the Golden Gate Bridge from Facebook to the Golden Gate Bridge from Wikipedia, we will have two POIs in our system that are the Golden Gate Bridge. And when the user will search for attractions in San Francisco, he will get two POIs, and that's a bad experience. So when you're doing your entity resolution and when you're measuring how good it is, remember to be unique. It will help you later on, and it will save you trouble and time. So just to summarize up this talk, handle new and updated content with care. Have reports, have tests. Measure your data, analyze it, feel it, get to know your data. It will help you. If you have long processes, break them down. Find the bottlenecks and fix them. When you're adding new content, you want to be fast. This is a crucial part. Create well-defined methods that you can use to integrate content. And if you see a specific issue, such as the rock example, it's probably all over your system. And it's not just this POI. You will probably have other POIs with the same issue. Thank you very much. Have a safe journey. This is a picture from Australia. Unfortunately, this is me in that picture. And yeah. Any questions? Yeah.
So how do you deal with
Yeah.
reports have different names, and also for sites and points of interest. Do you have? I mean, that seems like a huge.
Yeah, so unfortunately there are countries that don't talk English, don't speak English, and such as Israel. And also, even, for example, recently, so addresses in Germany are the other way around. You have the street name, and afterwards you have the house name, or the other way around. Yeah. So, and also in Israel. So yeah, it's very hard when you enter to a new location or country. You need to be able to know what you're dealing with. It won't be automatic, but running reports and tests will let you identify these issues pretty fast, because you'll see that you're adding new airports to your system and they're not matching to any other airport. And this is probably because the addresses are different, or maybe it's because no one can understand Hebrew and the names are in Hebrew. And well, yeah, you need, I mean, it's a work in progress. Yeah. Any other question? Yes.
How much time do you actually spend on, like, how do you share the time when you handle data like this? How much is like manual testing? How much is like
Yeah.
users? How much is it actual coding trying to fix? I'm trying to figure out what the balance is.
Yeah. So there are 3 types of tests that you can run. There are statistics that you can run on your data. There are benchmark tests that you can run on system level. Automatic tests that search for attractions in San Francisco and try to see if the results are what they should be based on all the results. And the last one is manual. But the manual part can be done by different people or even your users. And there are a lot of new tools out there, such as Mechanical Turk and Crowdflower. And you can, like, I think, very cheap, you can get an understanding of what's wrong with your data and to annotate it, and then maybe even create classifiers that will try to tell you when your data is bad. But that's one part of it. And so if you create more automatic testing, it will save you a lot of time. You can't do everything manually, because those are millions on millions of POIs. And also, when you have the content methodology and you start with a small amount, like a small sample, then you might identify all of the issues that are represented on all over the new data. So writing new code really depends on the new features that you want to extract from your data. And if you feel like you can get more of it, then you'll add the ability to find the POI categories from the POI name or from the POI description. So while you're looking at your data, you will always find more and more stuff that you can do with it. So there's always something to do with it. It's a never-ending. You don't reach a point where you say, okay, that's it. The project is mature enough, and I don't need to do anything else.
When you spend your time, how much is it? Like 40% goes into writing
Okay.
this, 20% goes to writing new features.
It depends on what you say a new feature is, because you might add new content, and the new content might be a new feature, such as hotel's availability in your system, or airports. And when you add new data, it opens new doors to add more functionality. I'm not working on that anymore. The company was acquired last year, but it was every week a new feature into the system. However, analyzing the data, normalizing it, fixing it, and the content acquisition is it's the most time-consuming part. And you need to know when to say enough. You can always do more, but that's the most consuming part. Any other questions? Okay, great. Thanks for having me here, guys.